Hello. All right, let's start working on gameplay. I've decided I'm at least going to add an option for Bezier curves to this red camera path, and then I'll decide if the Bezier curves is actually what I want in the end. And I haven't programmed a Bezier curve for a while, so I'm gonna have to remember. I think you just take the first and last points and interpolate the interpolators, I believe is the way. I'm just thinking I may not even want to put these. I may want to connect these in a different way instead of just setting the transforms. Let me think about this. This first one won't have any last connection. So we gotta get the connection of the connection. Might even need to get the connection that we're connected to as well. I'm not sure. I'm thinking if there's a better way than looking through these components of all the connections. So yeah, I think interpolating this direction we linearly interpolate between these. Yeah, I think I'm doing this wrong. From my understanding of this should work. First off, it should add deer. Then eventually it should add deer 2. Unless deer 2 is just straight up invalid. Yeah, I did something to my code. So this should be a A. I guess maybe deer 2. Form, position. Miss the end. Yeah, actually, I don't know. This should go that direction, but it doesn't. Oh, this is supposed to be dot connection. Now it works. Hey, Namori. Trying to do Bezier curves from memory. Oh! Oh, I think I might have it right here. At least the beginning of it. So then this needs to take into account the last interpolator now. I think. I'm just gonna look up the source code for Bezier. It's an emote from Twitch two-factor authentication. Huh. I think quadratic Bezier curves is what I'm going for. Linear Bezier curve is a straight line and is equivalent to linear interpolation. Function 1 minus t Oh, never mind. Yeah, I interpolate the interpolators. Oh, okay. And then your interpolant of corresponding points on the linear Bezier curves. P1 minus P2, 2 times 1 minus T, plus 2T times P2 minus P1. That's the derivative, though. I'm not sure what this sign means in Wikipedia math. Rearranging yields 1 minus T to the power of 2 times P0 plus 2 times 1 minus T times T P1 plus T2 times P2. Okay, I think I get that actually. So let me try writing this as an interpolator. Start plus end plus end 2. And then this value L is our T. Alright, so P0, 1 minus T times to the power of 2. And then 2 times 1 minus T times T. And then this one's just T times T. Yeah, just T times T. Alright, let's see if this works. This rearranged equation is actually really interesting because it's kind of the opposite of how I think about it. Alright, that's kind of working, but it's stretching too far. And where are these being rendered? Wait, but then this is starting from here. Every time I need Bezier, I just copy IQ function from shaders. Yeah. I normally don't use Bezier curves. I normally don't use a lot of quadratic stuff. So I actually need to take into account the before and the after. So this starts on 1 point. Oh my god, I get it. I get it. So for this, the Bezier actually become combined paths. Like, this is actually covering the span of 2. And then this one should actually cover here to here. Oh my god, I understand it. It doesn't... Unity should... This in functions as 3D curve. Yeah, I could... I don't know if the curve supports 3D like this. But Unity generally does provide stuff for evaluating curves. Where is it? There should be a... Weird. Normally there's... Maybe I'm blind because there's just so many things. Or maybe it's under like window. But usually they have like a tool for creating curves. Huh? Go to as 3D curve, allow to get 3D position based on length from start to beginning, like 0 to 1, and also for smooth curved edges. Yeah, that does sound exactly like it. Unity 3D Bezier curve. Oh, I think what I want is a spline. So there is a wiki page on it. So it looks like what this is doing is it's multiplying the P0 by 0.5. Or it's not doing times 2. I honestly don't know. So it's not doing times 2 at the beginning there. Yeah, so this is the same algorithm actually that I have. It's just how they're determining the control points is different. So they're doing half of this, half of the first 2 control points mixed together. Then P1 is just the middle control point. Then P2 is the middle control point plus the... Okay, so try that. How many is that total? 1, 2. He's just using 3 here. I'm just thinking, is the trick really just to do a mix together like this? Will that work? No, that didn't work. Oh, wait. It did work. Why did this break, though? There. Oh my god. Oh. It is working, though. So the Bezier makes it start halfway. I think I'm just gonna do what I mentioned before about the middle control point. So why did that create a direction of down? Yeah, okay. I don't like this way of doing it, of mixing the points together. I don't like how it starts halfway. There should be a way to do it so it lines up. I'm just thinking, though, to have it actually line up with the points, like there'll always be this either middle control point that doesn't line up with it. So there's either I kind of waste a point and have a middle control point where every other one actually places them. And what does the other way do? Yeah, I think I'm gonna do the midpoint where I can actually control it. So I'm just thinking, instead of connection, maybe control point. Bezier control point. Alright, so that's going to draw it without the Bezier connection. So I'm thinking, do I want to actually visualize the Bezier curve? I think I do. I think I do want to visualize the Bezier curve. I'm just trying to think about this as derivatives. The way I used to write this when I did it before was, instead of interpolating each of these 3 points, I started out at like p0, and then I did like the derivative from p1 to p0, and then I did like the derivative from like p2 to p1, and then I like interpolated those. I might try doing that again just because this math is kind of fun. Oh yeah, and then I think I also need to interpolate to control, don't I? Maybe, let's see. Start to control. Control being right here. And then interpolate control to end. What if we just do end minus control? Oh, this is transform dot position, not connection dot position. Oh. That actually explains it. Wow, I think I did it. So the way that I was thinking about it before, I should have just did what my brain was thinking of in the beginning. There's our curve. Technically this is like a parabola, right? Or is this quadratic? Brain go burr. Man, it's not that brain go burr, it's that Wikipedia math fucking sucks, dude. Like, who actually reads this and goes, oh yeah, this is beautiful notation. I know exactly what this is doing. Who? Who? Like, actually, I've seen... Man, I used to feel bad about this, and then I started seeing people on, like, the shader toy community, like, talk bad about like the math notation and stuff, and now I feel like compared to programming, this stuff is just bad notation. I guess it's like personal opinions, but um, also, like, I felt bad about complaining about visual scripting the other day and saying like, oh, Unity's focusing more on shader graph now instead of their like actual shader programming language, and then the people on the Shader Toy channel were talking about how visual scripting will never replace actual programming. It made me feel better about my complaints that other people are in the same type of deal or feel the same way. Now I can also write this. I think this is actually probably the most efficient way to write it as well. I read full Wikipedia page about Vanishing Point. My brain was dead. Shader Toy had no implementation of Vanishing Point with MIT license, so I had to make my own. Cross ratio metrology example. Huh. Calculating this seems like a machine learning problem. Yeah, actually, I think this is less efficient. Doing it, I actually understand everything about computer graphic and vertex and world and screen space. Ah. Alright, so now I'm curious. Let me try writing it this other way now. So yeah, I think this is more efficient because this is only doing 3 vector multiplications instead of 4, and instead it does more float multiplications. Let me think about this. So it's got one more vector multiplication, which is actually 3 float multiplications. So then instead here, it's got 1 extra multiplication, 2, 3 multiplication, 4. Wait, this is actually one float multiplication slower. I don't really give a shit. I'm just really curious about like what is actually happening when you do the math here. I understand this more than I understand the quadratic form from Wikipedia, so I'm gonna write this. So this is actually this is different now. So the Bezier is actually going to change the spread. So like this length is no longer going to be the length. The Bezier, how do you calculate the length of a Bezier curve? Calculate length of Bezier curve. I think split the curve into n segments and sum the segment's length. Arc length are only closed form for linear. For cubics, it's not a guaranteed solution. Okay, well, I'm just doing quadratic. Oh, an integral. This guy's creating fractals when he's just trying to. Oh god, this is actually getting really complicated. Arc length of Bezier curves. Okay, I'm just gonna think about this. So first of all, let's think of best case scenario is your control point just lies perpendicular to the start and end point, which means the length is just the length to the start and end point. The worst case scenario is that this goes off to infinity, in which case this hangs halfway between the start and end point. So I'm pretty sure you can actually calculate this as the dot product by multiplying the dot product compared to the dot product of the direction to the control point compared to the direction of the start to end point, and then adding that you're missing some basic unity functional that include crane path and 3D curves. You're doing it look very overcomplicated it. I mean, I kind of want to understand how the Bezier curves work. I kind of am overcomplicating it by doing all the Bezier curve stuff myself instead of just copying people's code. But that's kind of the thing, is I want to understand how the Bezier curves work. And this is interesting now because, yeah, I didn't really think that it was actually a difficult thing. Estimate arc length is average between the chord and the control net. In practice, this is just averaging them. And I don't think any of the I don't know, at least for Unity's curve system, it actually doesn't give you a way to get the total length of the curve. Like, time goes to 0 to 1, but it doesn't tell you the actual, like, length of that curve. This is something I think I would still need to calculate. So I can actually sum that. You don't need length to move on it, but I do to calculate the speed that you move on it. Or like the ratio that I place these coins. Number of coins per full curve. Yeah, but I want to do number of coins per world unit. Alright, 77, and then if we lift it up really high, go up to like 300. You can calculate length then by tracking position change by time you move full curve. Yeah, but that involves actually stepping over like nearly every point of the curve. That's integrating. That is integrating. So that's the issue, is I want to try to figure out how to do this without integrating across the curve. Oh yeah, I think I need to do control minus end as well. So let's see how close that gets. Approx. Approx 38. Am I doing something wrong here? What is the control minus? Approx 069. Why did that put a 0 in front? Oh my god, I just realized it's doing these separate. It wasn't adding those together. Or it was adding them together but as strings, not as numbers. Okay, so 385 is actually pretty close to the approximation 358. 358 and 385 are actually kind of... So now does this get more accurate as it gets straight? Ah, yes, okay, so it basically becomes equal when the curve becomes straight. So then this length is actually going to change depending on how perpendicular it is. And wait, what happens? Oh my god, this is actually going to be really hard. I don't think I'm going to be able to just calculate this actually, because like, for example, what if it's nearly behind? So let's try this. 0.5 plus dot end minus start and then control minus start. So let me see, if this goes negative, that'll go down. This goes positive, that'll go up. I think we actually want this to be negative. $147, now it's down. So maybe I should be interpolating between these. Try 1 minus. Too big. So when this doesn't subtract, this ends up being... Maybe I just want to multiply the 0.5 by dot. No. Try lerping. before. Let's try limiting the dot product. So this way, if it's straight, it should be 1. So I probably want to flip these values around. So when the dot product is full 1, it just does the end to start. Alright, that's better. Now it's too low the majority of the time. I wonder what the dot product is when it's up like this. So up there would be like 90 degrees. So that's 0, that's 1. That should be about 45 degrees, I guess half. If I keep putting it up, does it get closer? What about putting it behind it? It actually gets pretty close when it's behind it. Yeah, I think this is going to be really hard to calculate. Simple formula for computing the length of a quadratic Bezier arc. Computing the integral. Not what I'm looking for. Alright, let's try approximating it just by adding the 3 together. This is giving me like half the value. Magnitude. This actually doesn't seem close at all. It's not a horrible approximation. That's actually the best I've found so far. I think that's the best I'm gonna get. I'm wondering about shifting. I still want to try to do this interpolation approach. Oh wait, I'm multiplying these by 0.5, but they're just supposed to add together. Alright, so it's... the approximation is too big now. Maybe multiply these by 0.5 depending on the dot product actually. That might work. I'm just going to try outputting the dot product now. Just want to make sure I'm doing this right as well. End minus start, control minus start. So how would a negative... how would the negative apply here? Me times 0.5 plus 0.5. So then at -1, I'll do control start and end. At 0, it'll do halfway between these two. And at 1, it'll do end to start. That might actually work. kind of close so far. Approximation still gets too big for these though. I think the approximation is just the best so far. It's pretty good, but how do I stop back here from being so much higher? Whatever. Whatever. I guess if I really care about it, I can tally it up and integrate it, but let's see if I need to do that. That's interesting to me that I bet there is an algorithm for calculating Bezier curve length. Like there has to be. It seems pretty, I don't want to say simple, but like it seems like it is within limits that you could do something like that. So now I need to think about this. So do I want to approximate the length and change the spread based off that? I think so. let me think. Control minus start would be halfway. Then end minus control. Can I get the length from that? So if this was straight and the end just goes, no, that won't include the end to control length. If they don't change. So if this one goes 0.5 across, this goes 0.5 across. I feel like I might need to multiply one of these by 2. Hold on, I just want to check something again. How close is that to the approximation? Oh, I didn't mean to press play. Do I have VR enabled? I can't remember if it was divided by 2 or 3f. I think it was divided by 2. I'm not sure how I want to do this. So then it's start plus d0 times t plus d0 plus d1 times t. Correct? Yes. Nice. All right. We got Bezier curves. So let me actually see, does this keep the spread if we pull it up really high? Oh, okay. So that doesn't distribute across the curve evenly. Oh, look at this. This actually isn't evenly distributed across the curve. More parts of... Oh my god. Oh, okay. So certain parts of the curve, or certain parts of t along the curve, have a different distribution. With points equally distributed along the curve, what you're looking for is called arc length parameterization. So you subdivide a Bezier curve at fixed interval. Resulting curve segments will not have the same arc length. You need points to be uniformly separate as possible, using linear interpolation and monotone cubic interpolation. What is monotonicity? Preserves or reverses the given order. Huh. I'm thinking there has to be a way to do this. So does the same thing happen here? Yes, it does. Some more points get placed along there. How do I prevent these from occurring so close to each other? I guess the trick is to literally trace this and only place cubes when it passes a certain distance. I think that's the solution. Like, you just have to trace through the curve. Bezier curve uniform distribution. Uniform density of Bezier segments. Yeah, so basically I need to split it into actual lines of linear segments and then do that. All right. So I think instead of spread, I'll need like a Bezier precision variable. This actually should still tell us what our step size should be. This will just take 2 small steps at this area. Oh god, did I just crash the... Oh my god. The for loop is based off this spread variable. So when I set this spread variable to 0, it's just doing an infinite for loop. Oh god. I didn't think about that. The dangers of just setting values without thinking about the actual code that so I'm gonna need to restart Unity now. That's completely my fault. Alright, so I'm just thinking... Oh, so that didn't save any of my changes. I'm just thinking how I'm gonna check if this is gonna crash. Hey, what are you working on from the previous chat? I'm guessing Bezier curves. Yep, I'm trying to place coins in my game along a Bezier curve. And I just had it, but then I crashed my Unity because I'm bad. You can see the Bezier curve here. But then I ran into the issue of calculating the length of the Bezier curve and then uniform points along the Bezier curve. And honestly, I'm starting to think that I probably should have just used linear paths straight from the beginning. Yeah, I need to add something that if I set this spread to 0, it doesn't crash. So if connection does not equal null and spread does not equal 0, there we go. Okay. Wait. Did it just... Okay, thank God. I thought it just crashed again for a second. I was like, no. Cool. Code Money splines are awesome. This for Treants and Roller Coaster free script. Does it include code for calculating the arc length? By approximation? Then that sounds just like what I'm doing then. Nothing actually came up on Google. Do you mean Code Monkey? Nothing came up under Code Money. Code Monkey came up with a YouTube video, but it doesn't show how to do anything. This guy is literally making a tutorial where he's copy and pasting code. Yeah, I'm not looking to just copy and paste someone's code. I don't think he shows how to calculate length in the video either. And yeah, this seems like huge overkill. Like, I don't want a whole API just for splines. Sebastian Long's code. I think he stole it. Like, that was a really weird tutorial. The guy was basically just like copy and pasting in sections of code and then going like, you do this, and then not explaining how any of it actually works. Yeah, just train a neural network to do the Bezier curve. That's some 2025 programming right there. All right. So we've got non-uniform distribution along the curve here. So what we got to do is we need to actually calculate how long across the curve it has moved and whether or not it's moved a far enough point where it should place another cube. So I can calculate the movement as I wonder if I should just calculate the difference between the points or how I want to calculate the movement. This is already good. So like the maximum step size here is actually the proper step size for where it should place the cubes, but at points it takes too small step size. So we need to actually measure how far in world space it's actually stepping and skip placing a cube for a few times. Like we need to keep a measurement of our actual world space movement. So step I think I'm actually just going to calculate the change in point like this. Can I post links? Sure. Move along a Bezier curve. Solution is we have to reparameterize the curve to make each step the same size. Yep. Video isn't available. Approximate the integral. I don't like this because this guy doesn't actually provide any like the guy doesn't explain which one's actually more accurate. So like the small straight lines, I'm assuming is like the Simpsons rule is an approximation, but the small straight lines are also an approximation. Like the smaller lines he makes, the less of an approximation it is. So like he might not even be comparing this accurately. But yeah, I don't like this integration just on a single segment. Yeah, I don't think you need to do an iterative method for every step of the curve. I think you can just keep track of how far in world space you've stepped. So I think there's a better way of doing this besides the difference between the first and last point. But I can't really think of it because it's a quadratic equation and it's probably not simple. So this works. So then we need to place cubes based off how many steps there are. So like if step bigger than spread, then we place cubes. So this is the hard part, is keeping track. We need to keep track of where along the step we're going to place the cube. So my issue with this is, it goes 1, it's going to move 1 distance. Actually, no, this might work. Man, I am micro-optimizing the shit out of this. I shouldn't be spending that much time worrying about optimizations, but I can't help it. So now this is the difficult part, is how exactly do we want to interpolate between these 2 points? So like if step is too big, let me just try placing them just along the point like this. Okay. That's actually already way better. Look at that. It doesn't bunch them up around there, but it skips. You can see it. It actually skips some points right here, and I believe that's because like this one, it's actually drawing 2 right there. So I think what I want to do is I want to do P plus I'm wondering if I actually just want to recalculate this and just like advance the t along this. No. I have to make it linear, otherwise I'm not going to be able to actually calculate. Okay, so let's do this. D equals point minus P D dot magnitude well, step is bigger than spread. Start plus P plus D times So now, this is the thing, is how do I interpolate along the step? I think I'll make a variable called st for sub t. And I almost feel like this should have step already included in it, but step plus equals so I think it's spread divided by the point. So if the point goes 1 across 1 unit, or say the point goes across 10 units, and the step is 2, 2 divided by 10, yeah, that's going to give it. Okay, so hopefully that'll work. Oh no, that actually broke it there. That actually made it mess up and put too many right there. Huh. I think you may end up creating intersection of bilinear surface. If you don't like ray marking and brute forcing, I don't know. So what is happening here? Why isn't it showing up here? But immediately after this, it's drawing one. I think this step may need to start out. If I do step divided by dmag. No. Oh my god, I'm interpolating backwards. Of course. So that didn't fix it, but that explains a lot. So now we're going in the right direction. Oh, and that ended up placing points that are actually off the curve. Oh wait, this is supposed to be plus point. I'm still interpolating wrong. Alright, and now it's placing one too close. Right there. Okay, so step equals 0. Step should actually start out at spread. Let me think about this. So it moves across. if the last one is already drawn in very recently, and that step is big, it'll start at the beginning even if it should start part way. That's closer right there, but then that messes up right here. It's funny, what I had initially where it just like randomly, it just skips points every once in a while was actually the best. When I just did that works pretty well. I'm wondering how to debug this. I actually know what's happening. So it starts out at the first control point here. It tries to interpolate to the end, which can't fit another point. So then it goes to the next one, and it figures out that it actually needs to insert a control point here. So I actually think this step, I need to do this like, I don't know, maybe 1 minus. Let me think about this. If we step past the first control point. Wait, did that do it? Oh my god, I think that just did it. Wow. Wow. So I just need a single point. So I got it. Wait, so all I was doing wrong was I had to invert this. Imagine actually thinking about something and figuring it out. So when it goes past this first control point, or this first point here, the linear point, it's already moved a distance of like, I don't know, like say it moves like 0.8 units, and it only needs 1 unit to place a block. It starts at that next control point, and it goes, oh hey, we're gonna get a block in like 0.2 units or whatever. It takes that step size of 0.8 and places it 0.8 units up when it should be 1 minus 8.8, which is 0.2 units. Alright, and so for the first one right here, we need to place a block. So I'm thinking step should maybe just be spread initially like this. But then that's it's kind of weird how it doesn't show up immediately at the bottom here. Let me think about what math is happening. So even at 0, t is 0, p will be 0, the movement point will be 0. So it should, wait, let me just try something. What is just start? Start should just be right here. Yeah. So then what about start plus point? Point should still be 0. Okay. So then if when step is spread, the first one here thinks we're already spread units along. I'm just thinking, is 1 minus what I really want to do here? So if these point differences are smaller than spread, then this will actually be negative. That's not good. So all my issues come from this beginning start variable. So I can't just invert it like this. So let's look at this at the beginning. Step equals spread. Let's say this is smaller than spread. So this will end up being like 2. So it'll be 1 minus 2. I should just do limit that to 1. That should work, right? No, it still didn't work. And it looks like that step between them is actually closer. I still feel like I'm not doing this right. It looks good, but I still feel like it's not completely right. I do think that was better when I didn't have that clamped. It was more even. And that one actually got extrapolated off of the curve. That one got extrapolated past the line. So it's good, but it's still got bugs. I need to fix this. I think I need to rethink how I'm doing this algorithm. Alright, so step is the total length along the line. Point will actually be... Point is actually going to be the last... Wait, we're actually going to need to... I'm actually going to need to buffer points as they stack up. To cover a short distance. Oh my god. So when it goes a bunch of short distances... I can't just like interpolate halfway along. That's the thing, I actually need to go backwards in a sense. When I figure out that I've gone far enough to place a point, I actually need to go backwards to one of the initial points. Place the cube on the curve there. I gotta think about this. I'm gonna go get some water. I'll be right back. Alright, I have a theory. First of all, these boxes are actually correct, and it's the red line that's wrong. The red line has too low samples. What if I do 0.01? Oh, no, never mind. Alright, so that's wrong. That gets extrapolated past the line. So let's think about this. Step starts out at 0. Should move enough distance in one segment. So then I'll keep adding until step is smaller than spread. So I see what's happening. It assumes that it's going to move far enough to fill in one of these every single time, I think. It's hard to walk through step by step, but that's the best thing I think to do is the rubber duck debugging. Alright, so assuming it's still just at the second point, everything will work the first iteration. This will be start plus 0 times 0. So then the second step, we'll add spread or step spread slash divide by the magnet spread normalized to the current interpolator. So then the issue becomes, though, when it misses one surface, or it misses, it's too small to fit in a cube. So then step stacks up to some value like 0.4. So that is pretty good, except for this point right here where it doesn't properly save how far it's stepped. So I think maybe step mod spread might be what I'm looking for. Maybe spread minus step mod spread. Oh, and maybe divided by demag. Mod spread minus demag. So let's try 1 minus. No. spread 1 minus. So I need to do 1 minus, but have it do fract afterwards. So let me try this. Step by dmag mod 1. No, that won't work. Yeah, so that causes too big of a step right there. So let me think about this. If it steps too far past the first one, so it actually needs to go and put a point. Okay, so it measures the length from the first point to the second point. And that's not enough, so it measures the second point to the third point. And then it actually needs to go back and place a cube on the somewhere between the first point and the second point. Okay. So that's where a bunch of the difficulty comes in. I actually have to go backwards to I need to save more than just point here. Save like P0 and P1. I shouldn't need to do that though. I should just be able to place it somewhere on between so what's happening here where I think this is where it's not keeping track of the middle step, because this works good. There's not enough distance here, so then when it goes there to there, fills it in, and like this curve looks good for the most part. So then when it adds the curve, the next step isn't taken into account. Oh, so I actually need to take off a little bit of spread when I do this. if I do this, I actually need to set step to 0. So let me try that. If step bigger than spread, st equals step mod spread, step minus equals st equals 1 minus divided by dmag. Huh. Now that just skipped a whole bunch. Equal to spread. Is it just because of epsilon? No. Step minus st. What if we don't do 1 minus there? So, I'm wondering where the cubes are that are going around that curve there. Like, are they just not displaying because the number is infinite, or what is happening? So I really don't think it's the 1 minus, because that makes the beginning start out wrong. And it makes it go past the end. Maybe it's minus. It looks alright, except for this point where it double repeats. Oh my god, it's so close. I think this is good learning experience for me though. I'm definitely getting a better handle on Bezier curves. So let me think, does ST do anything? Does offsetting the step by this do much? I wonder if this is one of the points where it steps and it gets nearly a full distance and then it steps again and it gets nearly the full distance and then it goes. Hold on. I want to test. What if I decrease this length? Okay, so this should technically make it more blocky. When the algorithm is working properly, there shouldn't be any close together like this. You can actually see the uneven distribution here now. It's like a bunch of mini Bezier curves now in terms of distribution. So that almost seems better, except for right here where it jumps a large distance. And then that nearly works properly. What? Yeah, and so as I make this smaller, it makes it repeat. So this is interesting. This seems like it's doing 1 line, 2 line, and then where's the third line there? I guess that's the precision error. Yeah, so the linear interpolation here is actually working. Like, that actually looks fine. But then, yeah, as I switch up the points, so that's a segment. I should actually visualize this. Spread times 10. So I'm gonna try to make it match up with this red line right here. So this should be 3. 1, 2, 3. 1, 2. Is it's 0.33333. Okay. So it's pretty close. It actually looks pretty decent right here. This might be too far. It's hard to tell with the Y. Okay, yeah, the distance between that and that is definitely too high. So you can see the actual step size there. And this step's way too big. So what's happening there? Why does it only... I guess that's maybe just not quite enough for 2. So what's happening there? It has the extra step size right here. So then when it moves across to there, it should still have a little bit extra step size from right here. And this is 0, so it doesn't offset it at all. Let me try doing this offset. Yeah, so now that's going to break it. Okay. Now I don't know where that point went. Okay, so I kind of get an idea of what I have to do. There's not enough there's not enough on this line to fill in another point. So when it gets to this line, it ends up putting a point right here, when it should actually place one like halfway on the last line right here. So yeah, it's actually really challenging. Or not, it's not like insanely challenging, but this is actually a really good programming problem. I think part of my issue is I'm also trying to solve this efficiently instead of just like brute force searching through. So whether or not it places another one here, let me think about this actually. Okay, that doesn't seem right. It places one halfway across right here. This one should be able to move across to like there. So what happens if I do +1? Just draws the end of each point. And if I do half, do right here. So step plus equals spread. This demag might be wrong then. Yeah, look at, why is this moving over there? I'm definitely doing something really weird in my code, where it passes this point and all of a sudden it goes over there. So you can actually see the point where it repeats is actually getting smaller. What if I did wall bigger than 0? Oh my god, was that really the play the whole time? What is happening here where this is just all of a sudden teleporting over here? That I don't understand. I must have something messed up in my code for this to be happening. Hello, BS Wednesdays. Is it Wednesday? No, it's Thursday. Okay, so this actually works. Then this will put negative, this will put the spread to negative, or step to negative, which is actually fine. Because then next time it'll take longer to do the step. So now I want to see if I can fix this where two of them get really close. Right here. Oh, at least that bug doesn't happen where the cube goes flying into to nowhere. So my issue is now, with this going while bigger than 0, then it's going to be placing them here part way. So that bigger than spread was also what stops it from doing that. I'm gonna go get some water. I'll be right back. I think I'm gonna put some music on and try and concentrate on this. look at that uniform distribution. Alright, I need to see if there's an on selected children, on Gizmo selected but for children. Because I want to display these cubes even when the child is selected here. If selection. Okay, so I can just check selection. Bro, what the fuck is this doing in my YouTube suggestions under on Gizmos selected but for children? What the hell, YouTube? Wow, I actually don't think there's an easy way to check there's a parent. Yeah, you just need to literally just recursively check. Okay. Okay, so it's running the code. For some reason, this isn't returning true. Selected object, parent. I think this needs to be equals transform. Ah, of course it does. Okay. Woo! We got Bezier curves. Look at that. Look at that beautiful Bezier curve. Look at that. Oh my god. Alright, I'm gonna get off soon, but there's one more thing I wanted to try for the gameplay. Yeah, Nomori, look at this. Look at this distribution. Look at the distance between them. It's perfect. It is perfect. It only took me all afternoon. I think it's so hilarious though, because I actually could have just copy and pasted someone's code. But it's not the same. I understand what's happening now. So what I want to try to do here is put some sort of like I want to put cracks on the windshield here. I don't know if I'm going to be able to do that with just this glass material. I think I might need like a custom material or something. Man, this Warhammer 40k Mechanicus soundtrack is so good. Like the drums in this, just like... I should actually do some music production sometime soon. Because I'm gonna want some background music for this game. Okay. How? I'm just wondering, what if I just make a second ship? What if I literally just duplicate the ship here? I'm thinking I just duplicate this and then just replace the whole thing with a material of, like, cracks. Like, can I just duplicate that? Cone 1. And then I just do a single material. Maybe make it a little bit smaller. Say do it for learning, so it's worth its time. Yup. And that's not... Yeah, Bezier curves aren't even like a Unity thing. Like, that helps for shaders and so much. Alright, so this is gonna test transparent. I think we're gonna want alpha blending for these. And we're just gonna render the back face. Alright, so this is our test. So this is the red area is where the cracks are going to appear. I think that'll work. Ideally, I'd probably want to put it on the chair and stuff too, but I think having cracks and stuff appear in these areas is like a good visual indicator. So at the beginning, I might even just have this transparent and just turn it red as you get damage, just to represent it. Anyways, that doing that Bezier curve for like 3 hours kind of exhausted me, but I think we still made good progress today. Like the game is looking pretty decent, I think. Look at how decent it is. I can't even control it or anything. Oh god. What did I... Oh my god, did it leave it in VR mode because I crashed the editor? It did. It did. So overall, I think the game is looking pretty decent. Let's see how these Bezier curves look. Oh my god, I forgot to actually... It's still placing the coins in a flat line because I didn't actually add the Bezier curve code to the actual coin spawning. Classic. I actually feel like mouse controls will actually be easier for steering than keyboard. Like, I feel like I should flip the steering control so it uses mouse. Right now I'm using keyboard. I feel like actually I should use keyboard for look and mouse for steering. It's hard to decide. Alright, so I'll add the Bezier spawning code here. So then instead of draw wire cube, we just do instantiate instead. see this works. I'm fairly certain it will. There we can see our coins spawned in a Bezier curve. Beautiful. And hold on, it doesn't take much time. Let me flip the controls between mouse and keyboard. So I'm actually just gonna... I'm just gonna disable looking currently. Oh my god, what is... Oh, the sensitivity is way too high. Oh yeah, so the mouse actually has an issue. Where if you spin around too fast... Yeah, the mouse is kind of weird actually because it doesn't 100% match up. And values can actually be way higher than... Yeah, so mouse delta is hard because the values are unclamped. So I actually think keyboard was better. I still feel like I could give it more... Alright, let me try upping the acceleration. I still feel like it could be more responsive. Maybe if I do 1e6 acceleration. I'm curious how this will change it. Oh, weird. So now it's in like big jumps. Yeah, never mind. So yeah, I think I had it decently before. How do I turn down the steer sensitivity? So I think I'm gonna start by making a really bad ship that doesn't fly well, and then I'm gonna work on nice handling for a fast-moving ship. I still don't know if I'm happy with the movement. So there used to be drag before, where when you turned around it slowed down a fair amount. And it doesn't seem to be applying that. It doesn't really seem to slow down when you turn around. And and I'm fairly certain I know why. It's because of the high acceleration, but like, so basically what I want is like responsive turning but low acceleration. So there you can see it does some weird stuff where instead of turning around slowly, it like does this quick turn. So yeah, I think I'm actually going to try to redo the movement system again or come up with something better, because I'm still looking for something that has the right amount of drag. And this definitely doesn't have that right now. I think when I did this before, it did. But now with this constant acceleration, it doesn't. So I'm going to work on that tomorrow. That'll be it for... I think that'll be it for today. I might do a stream tonight. I'm starting to get to the point where I'm like enjoying this Unity development, or I feel like I'm almost at the point where I can actually just focus on developing the map without worrying about any of the programming. Or like, what ends up happening is I keep going to develop part of the map, like okay, I'm gonna place in these dust particles, and then going, oh well, I'm not happy with the way Unity's particle system's working, let's program our own volumetric fog. So I feel like just like going with what Unity has will make it way nicer, but I'm not happy with what Unity has. I really don't like a lot of the default stuff Unity provides, so we'll see how that goes. I'm happy with I'm overall pretty happy with how it's going so far though. Like it looks honestly graphically better than I thought it would. I don't know why I thought I was going to have issues with the graphics with Unity, but seems to be able to get the style that I'm looking for. Anyways, thank you for watching. Hopefully I'll see you around. I'll be back again either tomorrow for more game development or tonight. Definitely tomorrow. I'm on Discord or Twitter if you have any questions. Thank you for watching. I'll see you around. Have a good day, good night, good afternoon, wherever you are. Bye-bye.